Algebra 1, Lesson 2. The first part of this is about angles. And we're not going to have a whole lot to write in this section. First we start out talking about lines. And lines that are in the same plane either intersect or they don't. And if they intersect, they are called intersecting lines. They cross at one point called the point of intersection. So down here with these lines, right there is your point of intersection. Okay, and then there's a special case where if the lines are perpendicular, and by the way, the symbol we use for perpendicular is like an upside down capital T. Perpendicular lines form right angles. Right here at the point of intersection, that's why the box is here. It's showing that's a right angle. All three of these other ones are also right angles. They just weren't labeled. If one of them is, the other three are going to have to be. If lines don't intersect, they are called parallel. They never ever touch, so there is no point of intersection. And, like it says here, the distance between two parallel lines is everywhere the same. That means if I drew a perpendicular line through here and measured that segment, it would be the same length as if I drew one over here or anywhere else between those. They're always the same distance apart. Okay, now angles. Acute angles are, well, they're bigger than 0 degrees, but they're also less than 90 degrees. Okay, greater than 0 degrees, less than 90 degrees. A right angle is exactly 90 degrees. So up above there we had the perpendicular lines. Those right angles are 90-degree angles. Obtuse is more than 90 degrees, but less than 180 degrees, because 180 degrees is a straight angle, and that's basically like a straight line. So you see, if you have two right angles together, that makes a straight angle. And that is what this is showing down here. There's a right angle, there's a right angle. Together, that's 180 degrees. That's a straight angle. Straight line. Okay, here's showing acute. These are less than 90 degrees. These are obtuse. They are greater than 90 degrees. Over here is showing the whole way around a circle. Well, that's 490 degrees, so 360 degrees in a circle. We're moving on to part B, polygons. All right, so polygons are flat, closed, simple figures whose sides are segments. Okay, they're flat, they're in a plane. You can draw them on a piece of paper. They're closed. So if you were in paint and you're like filling the shape, it would stay inside because there's no gap. Simple, I'll show you an example of not simple right here. Okay, so these down here are not polygons down here. This is not simple because the segments cross. This one's not a polygon, it's not closed. If I tried to fill this with paint, it would fill the whole screen. And this is not a polygon because that's not a segment. Segments are straight, and that is curved. Okay, so those are not polygons. And that's all we need to do with that whole side of the page. So going to the next one. Okay, these are polygons. They are flat. They are simple because none of the sides cross. They are closed. All the sides are segments. And you've got the names of them, and then how many sides and how many vertices. A vertex is the singular. It's just the corners. It's where the segments, where the sides meet. And you see for each case, the number of sides is always equal to the number of vertices. Okay, so let's get this filled in. Each segment of a polygon is called a side. Each endpoint of a side is a vertex. So here's our singular, vertex. The plural of vertex is vertices, like it has up there in the captions. For each polygon, it's off screen. For each polygon, the number of, I just said this, sides is always equal to the number of vertices. Okay. Now we have a chart with the names of many special polygons determined by how many sides they have. So, triangle, quadrilateral, pentagon, you're used to those. 9 is a nonagon, 10 is a decagon, and we don't often get up to the many-sided figures. Sometimes, though, we'll talk about some with even more than 12, and we're not going to go into any names higher than those. Just, it's an n-gon, or a polygon with n number of sides. So if there's some 15-sided figure, you could say a 15-gon, or just a polygon with 15 sides. So here we have, if a polygon has 42 sides, we would call it a polygon with 42 sides, or a 42-gon. Okay. That's really all we're going to do with polygons for the moment, except for talking about concave versus convex. Then we'll get into some specifics. Okay, so concave has a cave. It's got a dent. There is some segment you can draw that connects points inside the polygon, but it crosses sides. If it's convex, there are no 2 points in this polygon you will find where you can connect them and cross a side. Okay, so that's what this is talking about. Has a cave, has a dent. And concave has a cave, no cave. The sides all go out. Okay. Moving on then. I'm sorry, there is a little bit more about general polygons. Okay, so we have equilateral. Okay, equilateral. Lateral is referring to sides, so that means the sides are all equal, same length. There's little tick marks. Each one has one tick mark that shows they're all congruent to each other. They're all the same length. Equiangular means the angles are equal. Okay, all the angles are equal. That's why each of those little curves has one tick mark. They're all congruent. If it's a regular polygon, it's equilateral and equiangular. Here are some examples of regular polygons. Okay, a regular triangle is better known as an equilateral triangle. But when it's equilateral, it's also equiangular. We'll get into that. And then here are some others. So, triangles have 3 sides and 3 angles. The number of sides is always the same as the number of angles. The sum of the measures of the angles in any triangle, you may recall, if not, we're putting it right there, is 180 degrees. Every triangle, which is incredibly useful. Okay, we can classify triangles by their angles. Okay, if it has a right angle, we call it a right triangle. The other 2 angles are acute. Okay, if it has one obtuse angle, it's called an obtuse triangle. The other 2 angles are acute. If all 3 angles are acute, then it's an acute triangle. And if all 3 if all 3 angles are congruent, then it's an equiangular triangle. And since we know all the angles add up to 180, and all 3 have to be the same, they all have to be 60 degrees. Okay, we can also classify triangles by their sides. And if it's equilateral, as the tick marks are showing here, all 3 sides are congruent. So I'm going to put 3 congruent sides. Okay, and that symbol I just wrote is the symbol for congruent, and that means they're the same size. And here's how you spell it. Congruent. Okay, 3 congruent sides. Isosceles, 2 are shown here being congruent, but actually at least 2 congruent sides. Technically, an equilateral triangle is also isosceles because it has at least 2 congruent sides as well. If it's scalene, there are no congruent sides. They're all different lengths. Okay, now getting to use some of this stuff. These are things like you'll see in the problem sets. In example 1 here, we're just supposed to solve for x. They give us the degree measures of 2 angles, and we know all 3 have to add up to 180. So, whatever x is plus these other 2, they total 160, right? 130 plus 30 is 160. That has to equal 180. That means x is 20. You don't write the degree symbol because the degree symbol is already there. X is 20. That's that. Okay? Sorry, my camera keeps refocusing. I'll try not to move around so much. In the next one, we're solving for 2 different angles. They only give us 1. Okay, well, how are we supposed to do that? Well, you need to notice these tick marks, they mean that those 2 sides are congruent. And I forgot to have us write on the other side something extremely important we know, we'll prove later, is that if 2 sides of a triangle are congruent, the angles opposite them are also congruent. So we're going to flip back and add that in. But for now, I'm going to go ahead and write that x equals 50 degrees. Well, just 50 degrees is already there. So let's go back and add that in. I am so sorry about that. Okay, so we have space right here. I think we'll just put it there. Kind of goes along with the isosceles. If 2 sides are congruent, then the angles, so angle symbol with an S, angles plural, then the angles opposite those sides, are congruent. So we're going to draw, I know we have one right down there, but here's our isosceles. These 2 sides are congruent. Okay, opposite that side is this angle. Opposite this side is that angle. Okay, so then those angles are congruent. And it's okay to just use 1 tick mark here because these are angles. They're not congruent to those sides. We just know they're congruent to each other. Okay, those 2 sides are congruent to those 2 angles. So, back to this example. Okay, so x equals 50. Now it's easier to find y because we know 2 of the angles. So whatever y is added to these 2, which total 100, 50 plus 50, has to equal 180. That means y equals 80. Okay, and I'm circling my answers. All right, in example 3, we're supposed to be solving for 2 things again. There are no tick marks. How am I supposed to know how to get started on this? The 8s. That side is 8, that side is 8. That means those 2 sides are congruent. That means the angles opposite them are congruent. So x is equal to y. All right, well, we know every triangle, the angles total 180 degrees. This one is 110. That means we have 70 left that we have to split evenly between those two since they're equal to each other. So each one of them has to be 35. X equals Y equals 35. Okay, and you can check that. 35 plus 35 plus 110. Make sure that equals 180. Okay, now talking about some quadrilaterals next. So quadrilaterals have 4 sides. That was on that chart earlier in these notes. And if 2 sides are parallel, just have one pair of parallel sides. And to show that lines are parallel to each other, you put an arrow like you would do at the end of a line, but on the lines. Okay, so that is showing those two are parallel. That's a trapezoid. Okay, the other 2 sides are not parallel. If both pairs are parallel, it's a parallelogram. Now, this is also showing that those 2 are congruent to each other, and these 2 are congruent to each other. See, 1 tick mark matches up with that, 2 tick marks matches up with that. Okay, then special parallelograms. Okay, all 3 of these down here are parallelograms. It says so. Well, that one doesn't, but you'll see. Okay, so a parallelogram with 4 right angles is a rectangle. And again, in any parallelogram, opposite sides are congruent, so it's showing that here as well. And if it's an equilateral parallelogram, so that's parallel to that, that's parallel to that, but all 4 are the same length, then it's a rhombus. And a square is a rhombus with 4 right angles, and you can also say that a square is a rectangle with 4 congruent sides. You can define a square 2 different ways. So this is showing you the one you're probably less familiar with. That, though, is all we need to do with our notes right now. So have fun with your problems.